So for the second problem, let's try to solve it. Okay, so we have here Yumi and Mako were trying to recreate the perfect table for their climate change town hall meeting in the evening, with the outline of the table given below, and given that CDE, okay, so given that this triangle here is an equilateral triangle and ABCD is a square with an area. It has an area of 4y squared meters. So what is the area of triangle CDE? Okay, for this question in terms of y and in meters squared or squared meters. Okay, so for this problem, guys, we need to find the area of triangle CDE. Okay, so if we're going to draw it here, this will represent triangle CDE. And if we're going to draw a perpendicular bisector on triangle CDE, we can say that we can create another point here. Let's call that point F. Okay, and therefore that's a 90-degree angle on triangle CDE. And we've created another point, so that's point F. So in order to find the area of triangle CDE for this one, we have to recall our formulas for the special right triangles. So we have the 30, 60, 90 formula for the formula for the right for the special right triangles. So we have x squared of 3 and 2x. Okay, so that's gonna be 2x, where x is the side measurement of your equilateral triangle. So how do we know that we have again a 30, 60, 90 triangle here, that we're going to use the 30, 60, 90 rule? It's because of this clue. We have an equilateral triangle, so therefore the angle measurements here, they're gonna be 60. So this should be 60 degrees, this should be 60 degrees, and this other measurement, this should also be 60 degrees. Okay, so we now found the angle measurements for this one if we've justified that we're going to use the 30, 60, 90 rule. Okay, so so for this one, we need to find the measurement of the base of the triangle for this one. Okay, so why do we need to do that? Because we have the formula for finding the area of a triangle. That's 1/2 base times height, and we already know the base. The base of this triangle, the base of this triangle is just going to be, if the area of the square, so if the area of the square, guys, for this problem is equal to 4y squared. Okay, so if the area of the square is equal to 4y squared, okay, and we know that the area of a square is equal to s squared. Okay, so therefore we can get the value of s, okay, the value of the side measurement of the square, by getting the square root of both sides. Okay, and what's the square root of 4y squared? The value of s is just going to be 2y. Okay, so that's 2y meters. The value of the side measurement of the square is equal to 2y meters, and therefore this side, the base of this triangle, must be also equal to 2y. So therefore we have here on this problem, that's gonna be 1/2 times 2y, and then what's gonna be the height of this triangle? Since this is a 30, 60, 90 triangle, and we know that CE, this line segment here, is equal to 2y, we can divide that by 2. So why are we going to divide that by 2? Because it's been bisected. It's been bisected by this perpendicular bisector that we created here. And what's 2y divided by 2? That's just gonna give us y, and therefore FE is just equal to y meters. Yeah, for this one. So therefore the area of we cannot yet solve the area of the triangle. We just know the measurement of this length here, the small length here, so that's FE. We can now solve for the value of the height of the triangle. So how can we solve for the height of the triangle, or sometimes we call it the aposem? Okay, for this problem, we can solve for the height of the triangle, but in this case, this is not the aposem, so this is just the height. Okay, so to get the height or the altitude of this triangle, we need to go back to our formulas. So since this is a 60-degree angle, the opposite of the side measurement of a 60-degree angle is equal to x squared of 3. Okay, so therefore, if this is x squared of 3, and we know that the side measurement is equal to y, so therefore the height is going to be equal to x squared of 3. And since we know that the side measurement okay, of this one, the one that's been halved, is equal to y. So therefore the height will be equal to y square root of 3. For this problem, the height is equal to y square root of 3. And if the height is equal to y square root of 3, so that's gonna be 1/2 times 2y times y square root of 3. So let's try to write this formula over on this side. Okay, so therefore that's gonna give us a is equal to 1/2 base times height for the area of the triangle, and we know the base is just equal to 2y, and we've solved for the height. The height is equal to y square root of 3, okay, for this problem. Okay, so since we now found the height and the base, we can now get the area of the triangle. Therefore the area of the triangle is just gonna be, this cancels out, and this is gonna give us square root of 3y squared. Okay, there you go. So therefore the area of this triangle here, of the area of triangle CDE, is gonna be square root of 3y squared meters. And that's the answer to our problem, to our given problem for this one. And that's how we solved it.